Now let us learn a new word called transversal. Consider two lines L and M, and if there is a line N which intersects L and M at two distinct points P and Q as shown in the figure, then the line N is called the transversal of the lines L and M. If two lines L and M have a transversal N, they form a total of 8 angles as seen here in the figure. So the pairs of angles 1, 5, 2, 6, 4, 8 and 3, 7 are called corresponding angles. The pairs of angles 4, 6 and 3, 5 are called alternate interior angles. The angles 1, 7 and 2, 8 are called alternate exterior angles. Angles 4, 5 and angles 3, 6 are called interior angles on the same side of the transversal. They are also called consecutive interior angles or co-interior angles. Whereas angle 1, 8 and 2, 7 are called exterior angles on the same side of the transversal, or they are called co-exterior angles or consecutive exterior angles. So we have learned different types of angles formed by the lines LM and its transversal N. Next we will learn about few axioms and theorems relating to these angles. Next we will learn about the axiom of corresponding angles. If you remember in the previous lessons, we have discussed that a line that intersects two other lines at two distinct points is called a transversal of those lines. We mentioned them as lines. We didn't really mention if those lines were parallel or not. So here is a special case where lines L and M are parallel lines and N is a transversal. If given that, then the corresponding angles formed by the lines and its transversal are equal. That is the axiom of corresponding angles. So here, as we have seen in the previous lesson, we know that 1, 5, 4, 8, 2, 6 and 3, 7 are the corresponding angles. And this axiom states that those angles are equal. And as you remember from the initial geometry lessons, an axiom is something that is assumed to be true. There is no proof for an axiom. We take this as a given truth. And we will use this axiom to prove some theorems, which we will learn in the next lesson. Let's now look at a theorem. The theorem states that if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. So we have discussed what alternate interior angles are in the previous lesson. In this figure, angle 4, angle 6 and angle 3, angle 5 are pairs of alternate interior angles. The theorem is stating that these angles should be equal. So let's try to prove this theorem. So we have been given that a transversal is intersecting two parallel lines, and we are required to prove angle 4 is equal to angle 6 and angle 3 is equal to angle 5. So let's prove it. From axiom of corresponding angles, we know that when a transversal intersects two parallel lines, the corresponding angles thus formed are equal. In this figure, angle 1 is equal to angle 5 based on the corresponding angle axiom. We also know that angle 1 is equal to angle 3 because they are vertically opposite angles. If you observe closely, angle 1 and angle 3 have the same vertex and no common arm. So they are vertically opposite angles, and vertically opposite angles are always equal. We have studied that in the previous lesson. So from 1 and 2, we know that angle 3 is equal to angle 5. So that is one thing that we had to prove. Similarly, we can apply the same steps for the other pair of angles, and you can prove angle 4 is equal to angle 6. So this theorem has been proved. Now let's look at another theorem. This theorem states that if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal are supplementary. So let's recall what interior angles on the same side of the transversal are. If you remember, I told you that a pair of interior angles on the same side of the transversal are also called co-interior angles, and these angles are angle 4, angle 5 and angle 3, angle 6. So these are pairs of interior angles on the same side of the transversal. and the theorem is stating that the sum of these angles in the pair is equal to 180 degrees. Let's try to prove this. So we have been given that a transversal is intersecting two parallel lines, and we are required to prove angle 4 plus angle 5 is equal to 180 degrees and angle 3 plus angle 6 is equal to 180 degrees. So the proof for this theorem goes as follows. First, we know that angle 1 is equal to angle 5 by corresponding angles axiom. The axiom states that if a transversal is intersecting two parallel lines, then the corresponding angles thus formed are equal. So based on that axiom, we have written angle 1 is equal to angle 5. Similarly, we also know angle 2 is equal to angle 4 by the definition of vertically opposite angles. We also know that angle 1 plus angle 2 is equal to 180 degrees by the linear pair axiom that you have learnt in the previous class. The axiom states that if a ray is standing on a line, then the sum of the adjacent angles thus formed is equal to 180 degrees. And here, if you observe, we have a ray which is standing on line L and forming angles 1 and 2 which are adjacent to each other. So 1 and 2, the sum of these angles is equal to 180 degrees. So substituting 1 and 2 in 3, we can also say angle 4 plus angle 5 is equal to 180 degrees, because angle 1 is equal to angle 5 and angle 2 is equal to angle 4. So in this way, we are able to prove that the sum of the interior angles on the same side of the transversal is equal to 180 degrees, or they are supplementary. You can apply the same logic to prove angle 3 plus angle 6 equal to 180 degrees, and I'll leave that as an exercise for you. Next, we will learn about the converse of the corresponding angles axiom. We already looked at the axiom of corresponding angles, where we stated that if a transversal intersects two parallel lines, then the corresponding angles thus formed are equal. The converse of it is, if a transversal intersects two lines and if the corresponding angles formed are equal, then the two lines are parallel. So this is the converse of the corresponding angles axiom. So what this axiom states that is, if a line N, which is a transversal, is intersecting two lines L and M, and if angle 1 is equal to angle 5, angle 4 is equal to angle 8, angle 2 is equal to angle 6, and angle 3 is equal to angle 7, then L is parallel to M. Next, let's look at that theorem. The theorem states that if a transversal intersects two lines such that the pair of the alternate interior angles are equal, then the two lines are parallel. So in this figure, we have two lines L and M, and a transversal N is intersecting those two lines L and M, and 8 angles are thus formed. So for us, we have been given that angle 4 is equal to angle 6 and angle 3 is equal to angle 5. Pair of alternate interior angles are equal. So we have been given that, and we have to prove L is parallel to M, and the proof goes as follows. So we know that angle 4 is equal to angle 6. This is given, but we also know angle 4 is equal to angle 2 by the definition of vertically opposite angles. So from 1 and 2, we can say that angle 2 is equal to angle 6. But now we know that angle 2 and angle 6 are corresponding angles, and we are stating that those two angles are equal. So by the converse of the corresponding angles axiom that we just learned, if a transversal intersects two lines and the corresponding angles thus formed are equal, then those two lines are parallel. So we can say L is parallel to M by converse corresponding angles axiom. So in this way, we have applied the axiom to prove this theorem. Next, let's look at one other theorem. Lines which are parallel to the same line are parallel to each other. So let us draw three lines. In this figure, let's assume L is parallel to M and L is parallel to N. So what it means is these two lines M and N are parallel to the same line L. So we have to prove M is parallel to N. So given L parallel to M and L parallel to N, and you are required to prove M is parallel to N. So if two lines M and N are parallel to the same line L, then those two lines M and N are parallel to each other. That is the theorem. So let's look at the proof. Let us draw a transversal, and this transversal forms angles 1, 2 and 3 with respect to the three lines L, M and N. So in the first case, consider the two parallel lines L and M. We know that angle 1 is equal to angle 2 based on the corresponding angles axiom. If a transversal intersects two parallel lines, then the corresponding angles formed are equal. That is the corresponding angles axiom. Based on that, we have said angle 1 is equal to angle 2. So this is in the case of L parallel to M. Similarly, in the case of L parallel to N, we can say angle 1 is equal to angle 3 based on the corresponding angles axiom. So from 1 and 2, you can say angle 2 is equal to angle 3 because they are both equal the same angle 1. So but if you observe now, the lines M and N are intersected by this transversal and the corresponding angles formed are equal. Based on the converse corresponding angles axiom, if two lines are intersected by a transversal and if the corresponding angles formed are equal, then those two lines are parallel. So M is parallel to N based on the converse corresponding angles axiom. Hence, we have proved that if two lines are parallel to the same line, then those two lines are parallel to each other.